computational methods, workflows, and tools we have today, but it's also driving their development. So one thing that I would like to point out right from the beginning, even though you will see what seems like a transition from a more artistically oriented application or experimentation with computational methods and tools towards a more scientific one, apparently. But to my mind, one goal is shared throughout, and that is to expand the possible solutions based on architecture, to break out of this 1, 2, 3, 4, 5 X number of steps, which is a linear progression. First I produce this, then I produce this, then I produce this, and then I'm done. So getting lost is an art form. When you expand your design space, and actually the first decade of the work was really about getting lost and trying to find new surprises and possibilities through experimental work, and then finding the way back again and trying to in some way rationalize this. So a while back, actually to be precise, exactly 10 years back, I was asked to contribute a chapter to a book that was called Perpetual Modeling. And really what I tried to do there is look back over 20 years at that time and try and see how workflows have changed in our work, in the small segment that I have been active in. So it's basically a meta perspective looking at different kinds of processes. And I don't want to talk about these diagrams here in any depth, but they should just be here as a placeholder to tell you that once in a while it is useful, and that's why I said earlier on when I started, really enlightening to look back and to try and rationalize what was actually done and what has changed along the line. So today is another opportunity. But I took this opportunity more on a casual level to take you on this journey, backtracking. So when completing my study at the Architectural Association in the graduate design program that was then formed for the first year and run by Jeffrey Kipnis, we were not working with computers yet. But we were introduced to an approach that you might call a combination between design theory and design experimentation. So basically, we were breaking into a world of, one might also say formal expression, but also systemic interrelations between urban scale systems, etc., for which we didn't really have the tools. We had some first questions as conveyed and taught by Jeffrey Kipnis that led to weird results, and results that we could not exactly place in terms of a detailed architectural imagination. So we would get fairly abstract models like this one for the Sprebo competition entry that we were working on at the same time, that looked at some sort of enmeshing of architecture and landscape architecture, as you would call maybe these expertises today. So really, these kinds of experiments took place largely without the use of computer. Here and there some diagrams were done, etc., but most of this experimentation anticipated a kind of organicism, a kind of complexity of systems, a kind of complexity of a formal language that came then more or less in the development. Really, at that time, maybe Form Z was beginning to emerge on the market, and other people started working with animation techniques for form generation, etc. But it was all very experimental. And at this time, we were still not really doing this with the use of any computers. All of this became sort of a baggage, and it became a useful baggage to take along in this attempt of getting lost in order to find your way again towards unanticipated results. So with this as a kind of precursor, the first thing that we really did was fairly mundane. We just looked for computational tools with which we could model the level of complexity, whether in terms of formula expression or in terms of on urban scale, articulation of urban systems, circulation systems, green systems, whatever you have. We were looking for the tools, and we were initially just developing our ideas without the computer and then expressing things within the computer. But this is actually something that is so trivial today that there's not even a point in discussing this at length. So I go straight into the point when we actually realized that there are some tools there that we could experiment with. And we were surely not the first ones, but I think one of the first projects for us where this level of experimentation with computational tools was important was for a fairly modest installation that we did in Oslo at Gallery Rome, in which we elaborated this funny geometry, almost like a spaghetti space, if you like. And we did that by exploring animation techniques. As I said, we were not the only ones. There were many that were in this field and were trying to work with it. So we used a kind of process that dynamically unfolds in order to extract form from this. And this actually happened by just selecting somewhere a frame out of this animation or a series of frames that were beginning to indicate a certain formal expression. So it was relatively random. It was design experimentation. It was basically saying the outcome of this, the formal suggestion implied in the frame selected, is that something that we were satisfied with? And then the first thing you realize, okay, you have already some sort of aesthetic preferences that you might decide to suspend or pursue. But surely you also have an element of trying to rationalize what it really is that you're doing there. And rationalization comes in two ways. Can we find a way of actually constructing something? And also, do we have other criteria, like in this diagram up here, which indicates the space for humans to move around. So basically, we have a space that needs to be free and not intersected by structures. And then we have other elements like light sources, acoustics, and so on in this animated installation. Now, so basically, if I have to rationalize it to some extent, at least, we had here various iterative, potentially iterative processes, an animation still, or a number of frames taken to be translated into form. Maybe we liked it, maybe we didn't. Then if we didn't like it, we went back to the animation and did the whole thing again, checked it again. Checked it also against the other criteria. Is it possible to move through, etc.? And in the end, to gain from this process the controlled geometry for the construction of the installation, right? So in some way, you could characterize this as a kind of artistic search for a design outcome that is not anticipated, that has a certain rationale, and that satisfies certain aesthetic criteria. And yeah, we continue to experiment with this also on other scales. These are some extracts from an animation that we did on an urban scale, with the aim to produce a series of maps for a landscape design for a park in Norway. This was also the time that we received, for some lucky reason, sponsorship from Silicon Graphics. So we had a fairly powerful computer sitting in the office. I think it was a model called Oxygen with dual processor, and we had also the first time the chance to work with so-called voxel models, which are data points in space that could receive data of different sorts, i.e. circulation of people on the side, or distribution of vegetation, or water runoff on the terrain, etc. And we could embody this in some sort of data model. Don't forget, this was the time when the question of data came up, but not quite in the way as it is today. Data was, like for the likes of MVRDV, etc., an important generator of a design outcome. But what data, what process, etc. But for us, this was the first time that we really began to sequentially organize a series of computational tools to have not a one-step translation process from an animation to a form, but to have a multi-step translation process towards a series of urban systems, and also, of course, outcomes in terms of landscape surfaces. Here we were also then starting to work with computer-aided manufacturing tools, including milling, including rapid prototyping. So for instance, here you see an excerpt of this design of the synthetic landscape urban or landscape scheme down to a building scheme where we developed a pavilion as part of a contraction of that surface. Again, this was done with animations. So basically you can liken this process of getting from an initial step, which are these animations, to the proposition or the extraction of a formal result. And it's working through in terms of a series of standardized architectural drawings. So this was all interesting. At some point we thought, okay, can we begin to drive this with more targeted design intent, let's say. And by chance, we were invited during that time. Says here the free meeting will end in 10 minutes. The meeting host needs to upgrade to a paid account.
Oh no.
Is this an issue?
No, this is not an issue. It
Okay.
shouldn't be an issue.
Okay, it says time left 9 minutes 40 seconds. Oh, let's see. Maybe it will be over in 10 minutes, so I have to be very fast.
No, I will fix it.
Okay.
Take your time.
So we were invited by the New York Times into a design competition together with a whole bunch of other architects. And the New York Times wanted to have a designed time capsule, in quotation marks, that would be exhibited in the lobby of the New York Times building, and that should be able to last 1,000 years with some content about today inside of this capsule, and that the capsule itself should also express something about our technical state and sensibilities today. So we actually rewrote the competition brief. We basically said, well, if something ought to be stable for 1,000 years, it's probably not going to be the lobby of the New York Times. It's fairly unlikely that this building will be there in 1,000 years. So we basically thought, why don't we make several capsules instead of one, and place them in the ice of the Antarctic at different locations. So global warming, we started hearing about it, so we thought, okay, this is a problem, then actually maybe the ice caps might melt off. So that means that the capsules will be released into the oceans. So first the capsules have to be able to survive in the ice, and then they have to be able to survive in the ocean. Now, this whole idea didn't come from nowhere. It actually came from a story that happened at the time that some of you might have heard of. a container ship lost the container with these little yellow ducks, you know, that you play with in the bathtub. And they were dispersed in the currents of the ocean and were found in many different places in the world over a period of, I think it's still going on. They still find these yellow ducks in different places from that accident. So this gave us a logic, and we thought, okay, there's a kind of metastability in this system, ice, water. So, you know, the capsule will be exposed to air, it will be exposed to salt water, it might end up hitting some kind of rock. So some might actually be destroyed, but maybe some would survive. We developed the design again with a sequence of animations. And here, I think this was a relatively intuitive and scientifically not so quite sound process. We thought we needed to find a geometry that can survive the ice pressure and that can also survive floating in the ocean and hitting a rock. And so we thought of an inner capsule and an outer capsule. The outer capsule made out of a titanium alloy and the inner capsule made out of a ceramic that could contain argon gas to preserve a series of objects placed within the time capsule. This was done alongside, so the animation was done alongside with a lot of physical model studies, plaster models that were made by hand in order to study the form of the inner and the outer capsule. And our idea was that none of the capsules would be identical, that we would actually use the ability of the computer, meaning computer-aided design and computer-aided manufacturing, as a way of conveying the sensibility in the industrial shift from making many more or less identical copies of an object to making different objects out of a process. So the inner and the outer capsule, some more studies of this. And 3 years later, after the 9/11 attacks, not too long after, maybe 3 months or so after, in fact, probably exactly 20 years ago to date, must have been November 2011, we were asked together with other 49 architectural practices to make a proposal for a new World Trade Center. And this was done by Max Protek, who was running a gallery at that time in New York. And we thought, okay, you know, another World Trade Center, trade gets interrupted, you don't put the trade in there, maybe we'll do something else. We come up with something more symbolic. We come up with a World Center for Human Concerns, in which all humans have representation, even those that do not have political representation through a nation state. And we thought to embody this with two figures that are beginning to intertwine in such matter that you cannot really tell whether you're having one or two figures, also with a fairly large canopy distributed over a certain area here in the city. And we utilized the same process for this as in the time capsules. And, you know, so many times during that time and after, we asked ourselves, well, you know, okay, you do this animation, you have 10,000 frames. How do you actually, what is your rationale for taking 1 or 5 frames and developing a form out of it? And this kind of thing, I think, became a driver for subsequent development to try and rationalize more what one was doing. So here, the choice was relatively intuitive and driven by the ability of an architect to see a possibility in a form to develop further into an architectural project. This is basically what we had done for the World Trade Center. So you see some different renders of the elevation. And we were really trying to figure out, can we somehow detect some of the sculptural qualities that we were after this unintelligibility, whether we have one object splitting or two objects fusing, what is going on here. And of course, this is a very deep floor plate. It's actually built around the void space where the two former twin towers were. So then we thought, okay, maybe we'll do the structure of the new building as a kind of basket. Because if you have single structural cores and they get damaged by an attack or otherwise some hazardous condition, you have a structural collapse. But in a kind of basket, you can punch a fairly sizable hole without that necessarily sacrificing the overall structure ability. We have never really truly tested this proposition. It was on a hunch proposition, and it led us to further detailing the building and the strands which form the primary strands of that structure, tied together with the plates, are also the circulation elements, which basically meant that through the several hundred strands, you could find a different way to your space that you wanted to go to any time of the year. So then the issue was, can we begin to drive these processes more with a rational method, where this is slowly moving towards it? It says less than a minute now, so in case we get disconnected. Anyhow,
if we get disconnected, I'm trying to upgrade on this side. I'm trying to. I will send out another announcement with to continue. Apologies for this. I'm very sorry.
No problem.
Mirat, can you share the link on the chat?
I'm trying. Just give me a second.
Okay.
Yeah, let me just wait for 1 minute now, because
there's
no point with starting a new topic now.
Yes.
In case
I'm gonna
we need to move
we
to
need to
another
move,
stream. Yeah, sorry for that, Michael.
No problem.
I think there is this technical issue.
Yes, sorry. I'm gonna share a chat now. 1 sec. Oh shit. I think we are going to connect back to Teams now. Not Teams, but YouTube. Luckily, everybody came back, which thank you for coming back.
Yeah, that's great.
Yeah, Lydia, do you want to turn on your camera, or no? I'm just gonna
turn it off.
No.
You mean?
Yeah. Sorry.
Yeah, let's continue. I think Michael, he will.
Yes, I think I'm going to turn off my mic now, and please continue, and with greatest apologies.
No worries.
Thank you, Michael. Thank you, Mirat.
Yeah, so after many questions from others and from ourselves, how to become more intentional and intention driven in the process, the question was how to address some of the choices made in terms of tools and some of the choices made in terms of what becomes the underlay for the next design step. And so in the following years, we try to develop processes in design generation and generative processes that were multi-step and that had clear rules, and these rules were also clearly intention driven. So for this project here, where we wanted to have a box filled with structure, but at the same time have a structural logic, meaning a directionality and spaces left unintersected. So relatively similar to the first installation that I showed you in Oslo, we tried to find a rational process for this kind of design. So we needed to have for each of the elements in that space a starting position. And we needed to have some sort of process where these elements look for each other, can begin to connect and form a space. So for this, we needed to have instructions for the process in a series of maps, and for each point where to look for a neighboring connection. So this began to require quite an elaboration for the process. What are, for instance, the volumes not to be intersected? What are the floor areas not to be intersected? What's the circulation space not to be intersected? And how many different levels of hierarchy do we need within the system? Meaning a primary structural system, secondary structural system, tertiary structural system, one that forms a ground surface, one that begins to suggest and form the volumes in space, etc. So then we could run that process and evaluate the outcome. I'll talk about evaluation in a second, but you can basically see this is a generative process with which the different system layers are defined. So you end up with a ground surface, you end up with some volumes, you also have some structure connecting across in the areas which are allowed to be intersected. And then, of course, we needed to do a structural evaluation. We needed to see where there are not permissible deflections within the system. And we also needed to check what are the resulting light conditions within this building for it to be possible to operate as an interior public landscape. Now, so basically, we also got a fairly expressive result, but you can see that the process was beginning to be more intentional in this whole thing, which sets you off into a direction, I want to say that now already, where you're beginning to define more and more and more and more each step, and where you ask yourself at some point, what actually happens to that expressive freedom? I will attempt an answer to that, at least as good as I can at this point in time. So, you know, we started bringing also a lot of these processes into educational environment. At that time, we started setting up the Emerging Technologies and Design Master Program at the AA. We did some prototypical constructions driven by these kinds of processes, where you have maybe through a physical model an initial starting point for a material system, and then you check different performance criteria which are specified. For instance, does the rainwater run off nicely over these different membranes? Does the air flow nicely through these membranes? Do we get a good sun shading from this canopy? And if all these steps are satisfactory, we can have an output after the evaluation of something that can be constructed. But before going there, I actually have to just give you a general rationale for what's happening here. Why did we not make a big sail instead of so many small ones? This has several reasons. This canopy here sits on these columns, which are tied into very poor structure below. So with a horizontal load here, we get a moment that the structure where the column is tying in cannot actually cope with. So we needed to reduce the horizontal load as much as possible by splitting the large form into very small forms where the air can flow through. Also, those of you that have been at the A would probably know that somewhere back here where you can just get an idea is the Imagination Building by Ron Herron, one of the first buildings built by a member of Archigram, also with a textile membrane on the roof. And we didn't want to make the view on this entirely impossible. So breaking this open was also an issue of ensuring that this is possible. So if you have now such a canopy, you need to make sure that it doesn't rain under it so that you have sufficient overlap. You need to make sure while you're reducing the horizontal load that you don't accelerate the airflow so that it's very uncomfortable to be under there, and so on. So you can just, back here, you can just make out the Imagination Building. Some unexpected things always happen. This was the winter with the most snow ever in London, and I remember that between Christmas and New Year's, I had to go there with our engineers from Bureau Happold and evaluate whether we cap the tension cables here and let the whole thing drop into the courtyard, because it was beginning to be dangerous. But fortunately, we didn't have to. In other situations, also complex issues. This is on the Pacific coast in Chile, in the Open City Retalk, where we designed and built a number of projects. Among this one here, which has kitchen facilities in this volume and an outside seating area, protected a little bit by these sails here. And of course, on the Pacific, you have very strong gale force winds, which are actually even more destructive in this area than earthquakes, and they have a lot of earthquakes. So we had to come up with a way of making an iterative process that allowed us to modify the form, understand the flow of forces, and evaluate the new situation in terms of the horizontal load, the uplift, etc. on the structure. And in this process, we discovered that we could only do that if we have some elements that could change from compression to tension. So we actually learned that there was one way of handling the system, which was coming from the structural analysis, an instructive piece. So it was not just evaluation, we learned something about what we could do from this part of the analysis. Or in this case, doing a tensegrity structure here in northern Norway. For this, because we have now a highly irregular, unsymmetrical structure. So we needed first to develop a kind of computational system to even design such a tensegrity structure that is structurally valid, that is stable, and then run it through a more costly structural analysis here, in order then to have the output for the construction in this way. And so we went on, and the projects became more demanding. So then we had to do one for a community center. This was all designed and built with students, all done in one semester. So the computational process was there to handle complexity in a relatively fast-forward manner, then to go there and also to build the structure in the same semester. So for this community center here, here we are now inland in Chile. We don't have such a big problem with gale-forced winds on the Pacific coast, but sun is a real issue. So you see the building itself has this screen wall here so that it's possible to have windows behind, so that the whole space doesn't get too much glare and too much solar impact, meaning heating up too much. All the buildings in this area were destroyed by earthquakes in 2008. So we looked around what people built afterwards, and they built only now one-story buildings here. We said, okay, we adhere to that, but we make a roof terrace so that at least one piece of luxury, they can go up one floor and spend some time there. So this also needed some protection from the sun. In the design process, when we actually did the shading analysis of the membrane canopy above, we realized that this was actually helping the screen wall below at certain times, so that we could actually make a relation, parametric if you like, between the definition of the screen wall below and the membranes above. So by shifting the membranes over so that shading is provided over a certain portion of the screen wall, we would get the opportunity to have some more openings there. I will show you this in a second. So we needed to also then have a way of structural evaluation, and we did that with graphic statics in Grasshopper, because here we have a vector-based system. Everything can be translated into vectors in terms of compression and in tension. So this was not too difficult. And then you see here where we have the tree, it provides shading. We can have larger openings. Where we have the canopies, pulled down, we have the chance for larger openings because now these two systems work together in terms of the modulation of this enclosed space. Then this became sort of recognized within the context, and people started doing diploma projects on this. Here was one guy who wanted to do a kind of holiday home on the west coast of Norway. This is not very densely vegetated, so you have only these rocks. And this guy actually wanted to make the terrain form an important input. Luckily, the whole of Norway is scanned by LiDAR, and you can get the point clouds and basically the computational description of the terrain at a reasonable resolution on a public repository for this kind of data. So the data is publicly available, which basically meant we could craft an argument that you no longer have to go in and raise the site with bulldozers, but that you could start working with the terrain because the survey is already readily available. You only have to figure out during the construction process how you handle the unevenness of the terrain. So the idea in this project is to have an outer skin and an inner skin. The outer skin produces a transitional space, a little bit of shelter during transitional seasons, and then an inner hull that makes for a climate-controlled inner space. Airflow was an important factor on this exposed area in Norway. So the student actually programmed a custom-made tool for the evaluation of airflow input. So you see here around the circle, which indicates the prevailing wind directions. So you get a simulation of that, and you get the response of the form. Connect that back to the intention of having a form that can survive in the ice and in the ocean. So here, there's really somebody who is now bringing a rationale and the simulation tool in to inform the formal outcome with real forces. There's obviously also some evaluation that needs to be done. How much solar exposure? Do you get enough daylight? In the north, this is a really important thing. And how do you articulate the interior if the intent is the interior response to the terrain on the outside? How do you make this habitable? So you end up having a whole series of data inputs. The terrain-specific data, the prevailing wind directions according to seasons, and of course the sun path and angle as an input. And then the generative process that runs through negotiating the inner and outer enclosure, and an evaluation process, and eventually an output. Visualization is, of course, an extremely important element in assessing what you get there, also from perspectives which are not necessarily driven purely by the choice of data that generates a design, thereby by performative criteria pertaining to, let's call it, engineering considerations. But you also want to do a visual evaluation. And here you see two renderings for a bridge proposal in Oslo, also done by a student. But these renders take a lot of time, and the engagement is not very dynamic. So at that time, we began to utilize virtual reality as a way of moving through and doing other forms of assessment. And in this particular example, you have here these yellow markers. And if you get close to it, you can also get information about the dimensions of the structural elements, etc. Here another example. So now we actually made the whole issue one step more complex, in that we said, okay, we can do these tailor-made forms, these kinds of one-off forms, but what if disassembly and reuse in a different context is necessary? Could we even find a logic of configuring something that is so tailor-made into a different spatial and formal arrangement? So these were students working on this in 2015. So the first task was to design a pavilion for the Oslo Architectural Triennale. So this is a site in the city center. And then they were asked to come up, to use this assembly and come up with a different configuration for a small little research center on an artificial island in the Oslo fjord. So this started with the development of some system defining structure and surfaces, and habitable surfaces and other surfaces. And for a particular configuration, for instance, with membranes, to bring in computational analysis, because we understand the sun path, we know how much shading and how much thermal protection can be secured, but also how much daylight we actually receive inside. Remember, this is in the north, it's important. So it's a bit of a trade-off between shading and glare prevention on the one hand, but on the other hand, having enough daylight in there. Then we also built prototypical scaled models. We developed some Arduino sensor setup to do some readings in terms of what particular membrane configurations provide in terms of shading and daylight. And then we set up a process. Now, this is what you already know. This is how we develop a system, like, for instance, in the holiday homes that I just showed you. But now we had to be able to take all the elements that make this assembly as a stock and feed this into a new system for a second site with different conditions, or a third site with different conditions, and still get the result out of this. This was not a trivial undertaking. This was fairly complex, and I think we still have outstanding work to do on this. By we, I mean all of us, because disassembly and reuse is becoming an ever greater issue. And it's easy if you have uniform systems, I mean relatively uniform systems where all the structural elements have the same size, etc., and all that. But what do you do with tailor-configured systems, where maybe all elements, all parts in this kit of parts might be different? What is the possibility to reconfigure this into a different assembly that also fulfills particular performative criteria? For this, the jury is still outstanding, and I think more work needs to be done on that. But also we tried similar kinds of approaches on larger scales. This is a sensitive site on a very steep slope in Norway, in Oslo, on the Oslo fjords. So the fjord is down here. And we tried to say, can we have a way of distributing architecture here at high density, low rise, without necessarily having to raise the entire slope? We want green corridors for the animals. We want to protect some listed wooden buildings, which are really important. How can we do this? This is, of course, something to do with an extensive terrain study. Now we have to understand the development of the terrain really, really well first. And then we can do an analysis of the terrain. What this is a grasshopper routine that shows you paths which are implied in the terrain. Easiest paths with least amount of inclination between point 1 and between one point and another, so that you can get some likely paths of circulation through the system. Other types of analysis have to do, for instance, with surface water runoff. On these steep cliffs, you don't have much substrate that will take up the water, so the water runs pretty much on the surface, and this can cause structural damage, etc. So if you keep the terrain, you need to take this into consideration. At the same time, when you do something so dense, you also need to do an evaluation of each individual unit in terms of daylight, solar exposure, solar gain, etc., etc. So this is then a two-scale elaboration. Right? This is a workflow that was produced by the student, but really you had the scale of evaluation on the territorial scale with all the aspects to do with, for instance, vegetation distribution, surface water runoff, slope analysis, etc., and then also the individual units. So this we took forward, trying to develop this further as tools were developing. And in the Rhino grasshopper environment, all of a sudden, a lot of tools popped up for basically terrain evaluation. For instance, Bison, the plugin Bison. But this was mostly a tool used by landscape designers, not by architects or urban designers, because we always anticipate that we have some sort of pre-prepared tabula rasa site, which is flattened or prepared in some sort of way that we never face these kinds of problems. So we turned this around and said, okay, if we have these tools available, why don't we do a really careful analysis of the terrain? And then, based on particular terrain types, a slope, a kind of little valley or depression or such. And then for each one of these situations, we develop a particular building type that can be implemented in some way or another on this terrain. Then the next step that we need is a computational routine that recognizes these different situations on the site. For instance, the one for the bridge house that is spanning across a trough or a depression. And that will then say this kind of building type can be here, 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 and here. So in the end, you end up with something after distributing all the building types that looks quite messy, but it is in each case actually directly forging a close relation between a terrain feature that exists here and the building type that is suitable for this particular condition. Meanwhile, we have realized that in geographic information systems, there's something called geomorphons, which is a kind of terrain analysis that is pattern recognition based, which could make this process even easier. But architects and urban planners don't work with this. So here's a render of one of these distributions. And again, we also looked at a circulation path that would make the least change to the existing topography. And more recently, we then brought this entire process forward into a joint studio with EPFL in Lausanne in Switzerland. And here, in this collaboration, we were able to tap into the rich databases of Swiss Topo. That meant that we already had incredibly well-defined access to incredibly well-defined point clouds that describe the terrain. We could use them as a way of 10 minutes left before the next crash. Okay, anyhow, this would be the terrain form. We could actually map geographic information systems based data onto the terrain form to understand various things. For instance, exposure to sunlight, water runoff in this case, and so on. And we could begin to think of these things as a layered set of data that could feed into the design process. And wherever we were data missing, when we needed something more special, we could look into geographic information system simulation tools and produce this data ourselves through simulation. So here we have a typical flow. We have the digital elevation model provided by Swiss Topo. We have the geographic information systems based data, whether from simulations or already cartographic data, fed into a process where we combine this data, where we feed this into a form generation, or in this case, a volume distribution process in Grasshopper Rhino that can, through the use of an evolutionary algorithm, produce different configurations that can be evaluated. But in order to do that, as I said earlier on, you do also need to have the architectural instruction. You need to say which kind of programs and how do the programs relate, how do they translate into spaces, how these translate into types, and how do these translate into square meters, so that we actually have something particular that can be distributed. Yeah, so there's a numerical description, and then there are certain aspects for simulation, solar radiation, the analysis of the slope itself, the intersection with the terrain, etc. So normally this means a multi-step optimization process. Now, so that gives you, for instance, a function distribution, a unit distribution, and then what is called here types improvement, which basically means orientating each building in a better way towards the sun, etc. And through this, you can get a multitude of outputs that you can then evaluate, and you can have output and insight on on the scale of an entire settlement, and the relation of each unit to the terrain and to the existing vegetation. But you can also have the output on an architectural scale, where you can now really look in at what's happening for each one of the buildings, in particular in relation to the design parameters. So this actually leads us to the making of fairly elaborate workflows. This is now always part of our work. What is the input? Where's the input coming from? Something we surveyed ourselves, something that's already available, geodata that is available, for instance, through geographic information systems, the coupling and correlation of this data. Nowadays, we work a lot with voxel model as a way of doing this. And then this is linked to a regular process in CAD through which you establish then either your distribution of volumes or your articulation of an architecture, etc. So at this moment, we have just started a new research project, a Horizon 2020 Future and Emerging Technologies Open project called Ecolabs. And here, yeah?
Sorry, can I just interrupt? I know that this is kind of annoying. If we get disconnected, can we come back to this link?
Yes, we will do that, yes.
Okay, apologies.
So anyhow, this is about thinking about the building enclosure as a multi-species space, based on the understanding that we have not enough free area for green spaces in the city. So in fact, the gray infrastructure needs to make provision for green systems almost on an equal footing, because we cannot just say it will all take place in the neighborhood park. Because the neighborhood parks, they're maybe not networked enough with green systems. So in a way, if we want a real restoration of ecosystems in the cities, we need to involve all the architectures which we're constructing anew or that we're refurbishing in such a manner that in some part of this provision, animals, plants, and microbiota can take place. That means, first and foremost, a very big interdisciplinary effort in understanding the way in which human ecology, plant ecology, animal ecology, and soil ecology can work together and correlate. And then if you want to build a computational design framework for it, you need a whole set of different components. You need different types of databases. You need some way of modeling the information contained here, basically making information out of the separate, disparate sets of data that is actionable, and then feeding this into a process that can generate a design. I cannot show you any outcome for this because this is a project that has just started, but I just wanted to show you how complex things can begin to be. So here we're getting to the end, and here is where I want to remind you of something that I said earlier on. And one of the issues that we're realizing here is the more we rationalize the process, the more we wonder where is actually the space for creativity. And I think the answer is twofold. First of all, configuring a process that generates something is a creative process in itself. Then there might be a certain strictitude in terms of what is made into what. But for as long as you try to have multiple design outcomes that all can satisfy the set criteria equally, you can come in at the end again with other evaluation criteria. You can, for instance, say which of the design solutions satisfies you the most from an aesthetic perspective. At any rate, I don't think that the early experiments have now over 30 years become redundant. I think somebody, and many people do, have to do these kinds of light-hearted experiments again. because there we begin to find new insights. May they be personal, may they be more broadly relevant for the discipline, may they be relevant for addressing a certain design problem. So what I showed you last is beginning to become a very heavy-duty workflow, which is interdisciplinary. There are many disciplines involved. There are different types of computational models involved. It's so hard to even understand what will the ecologist give to me as a model, what will be the data output of it, and how can I utilize this in design. And then you have to answer this question for human ecology, plant ecology, animal ecology, soil ecology. You have to put this together. You have to bring architectural criteria in and so on. So there is reason for these heavy-duty solutions. In the end, they will boil down because things become refined. So it's not as clunky as it sets out in the beginning. But I would say this is not a replacement of the experimental work. It is experimental work of a different type, but I think the other experimental work that is more lighthearted and maybe a little bit sort of like not too many pre-rationalized elements guided towards design output are equally important and should take place in parallel. In the end, what all of this is trying to do is to expand the solution space, the space of possible design outcomes above and beyond what we normally do. This is what all the things that I showed to you today have in common. Okay, so this is it from me. I think we will be disconnected now, and then when we reconnect, we can maybe have a bit of a discussion.
Yeah, thank you. Thank you very much, Michael. That was absolutely fascinating and inspiring, especially that transition from the physical experimentation to the digital tools, and in order to facilitate and overcome time issues and multiple levels of complexities, and of course the endless possibilities of iterative processes. I think now we are going to move to the Q&A session, but before that, let's move to the new link so the Q&A session is not interrupted.
No, not the new link. Not the new link. Just this link. Just come back to this link.
Which one? What do you
This
mean?
one.
This one? The same one?
Yes, this one. Yes, this one.
Did I come first?
Yes, you were quick. We are live on YouTube with all the technical difficulties.
Yeah, no worries. It's totally fine. It has been a year, but still new. Come on.
Anyway.
I feel I'm mortified, but
It's totally cool, guys.
Don't stress. Don't stress, Matt. We're all here for you.
It's really nice. It's really nice. Come on. So what? It interrupts. So what?
Yeah. So let's hope Michael is joining back.
Yeah.
Would you blame him if he doesn't?
How did he join back earlier, Mira?
I sent him the link. I'm going to send him another link now.
Send the link again. Yeah.
Yeah, send it again, I think.
Until he joins us, I would like to thank the students came today. This is a good turnover, so thank you, guys.
Yeah. And keep coming back.
Oh, he's back.
Oh my God, like.
Thank you so much for coming back.
So, yeah. I think we had to rush the finish. We can't hear you, Michael.
Sorry, I just need to, I just need to open the door. Just a second, please.
Yes, please go ahead.
Unless you have your hand up.
Intentionally, yes.
Apologies, the doorbell was ringing, and then our dogs went bonkers, so I had to quickly do something about that. Otherwise, you wouldn't be able to hear me.
Yeah. Thank you again. I would like to repeat the thank you part. It was absolutely fascinating and inspiring, taking us through your journey and the way it evolved and the need for the digital tools. And also, I would like to thank you for your closing remarks and reflections, because that, I think, wraps it up and opens the stage for everyone to ask questions and where is that going to take us in the future. When you started, you said this: getting lost is an art form. So I think this is a strong statement, and many times students are afraid of it, but they shouldn't, because it's part of the process. And my question to you: how can this experience of being lost be controlled? So how can, what would you advise students and others not to feel that getting lost is not something to be afraid of, but there is a way how to control it and get the best out of it?
Well, first I want to say I do remember what it's like to be a student. I am still a student, actually, in some way, but the scariest thing for a student is when somebody tells you, find some way to get lost and find your way, because you are there to expect to hear how to do things, not to sort of be out in the wilderness. So this is actually a weird thing, and I am very grateful to my last formal professor, because I had a very poor design education here in Cologne, in Germany, at the technical high school. It was technically very good, but design-wise it was really very bad. So I was looking for something. I realized that I didn't have any process, no rationale to my design. And I went to England, and here comes this guy who tells us to get even further lost. Well, he didn't say it in these words, but he basically said, okay, forget about everything you do, we're now doing the new. And there are some criteria for it, and so now let's get started. So forgetting even more about things. Took me a while to realize what he really meant is not to operate on preconceptions. If you want to work experimentally, you cannot do that based on preconceptions. You do have to have some sort of imagination, and it's kind of hard to cultivate an imagination that is free of preconception. That's a really hard thing to do, and it's actually almost impossible, but you can actually train yourself to develop an eye for things which are not within the ordinary canon of your expectations. So you can utilize processes, and they don't necessarily have to be computational. They can be any instrumental process can be used to produce outcomes that you wouldn't have anticipated and that you would not probably have produced in this kind of way had it not been for a process. Everything that I showed you earlier on the pre-digital phase, all this design experimentation, had one thing. And that one thing was very clear. There was process behind it. We had a lot of exercises where we were told, okay, look at this image as a diagram, take it through 5 steps of transformation, but not irrational transformation, rational transformation. So explain what is happening in each step. It could be, for instance, geometric transformation. And then have a look at the result. And then describe the result in the terms of what you have in front of you and how far this is different from what you thought you would get. So this is a kind of training process, and it's an instrumental and a rigorous training process. And the first response is always, doesn't that lead us away from free creative thinking? But what is free creative thinking? Sitting there with a white sheet of paper and a pen, and then wondering, what should I do? Should I draw a line? Should I draw 2 lines? What should I do? Are these 2 lines right or not? So one is actually always searching for some way that brings a result. I don't think that instrumental processes and rigorous processes are contrary to creativity, but they train our eye, especially when the process is unfamiliar to us and we employ it for the first time. They train our eye and our understanding to recognize outputs that we would have never produced or anticipated and to start evaluating them.
Yeah, I think that's a good broad answer, and still like giving them some kind of a direction and some kind of an explanation why it's important to get lost, and then to use this design process or this rational transformation in order to get to a proposal.
Can I just say one quick thing?
Yes.
Obviously, getting lost, this was meant as a provocation. This is probably not the best way of putting it. No, it was just a provocative statement. A better way would be to start walking in a direction in a controlled way, but not necessarily the direction that you would have anticipated from the beginning.
Yeah, I totally agree with you that, but this is a word that is often used by students. Yeah, so I think it's because this is the way that we can define that it's lost, but it's not lost actually, because you are exploring, you are trying to find meaning and understanding of the relationships, the connections between the different things. And okay, it's a process until you get the grasp of that. And in the meanwhile, you think it's a loss, but it's not, because you are in the search of. So once you find it, then okay, it's there. But it's the process, I think, and not to be afraid of that and getting like different inputs. But the most important thing is to try to find meaning for these different things that we find on the way, and the relationships between them. So I think I will now go to the questions by the audience. So are there hands up, or those who would like?
Questions in the chat.
In the chat. Okay, let's go to the chat.
There's also a hand up I can see. Anas Lila.
Okay, so yeah, go Anas.
Well, I had my hand first, but no, you can go with Ed's question before, because I think it's meant to students. So
I prefer, maybe we start with you because you are already there. So
okay, no
go
worries.
for it, and then we go for the text.
Okay, cool. Thank you so much, Michael, for this lecture. I hope we get to invite you to the campus soon and get to meet you. It's an honor actually to talk to you personally. I like all your work. So
thank you.
Thank you for getting this very interesting lecture. My question actually, again, revolves around the idea of rationalization and stuff. So you talked about you transferred your work from, let's say, for the time being, the irrational way of producing geometries into finding some sort of rationality behind it to produce some sort of systems instead of just producing an output. This is something we usually struggle teaching with students. So I need to know what's the motives behind that personally, just to give them an idea how to challenge the ego, to put it down and try to find a system or a logic behind the product instead of just like going with their mind, going with their intuition. What did you make this transfer? How did you dealt with your own ego and your own like feeling of ownership and designership, if we can say the word, and trying to find the system that you rely your smart and clever skills into to prove that you're still amazing and creative and everything, but through a system instead of just through a final product. How personally, what was your process into that? I would like the students to hear this kind of story if you have it. And also another technical question about building in different locations, such let's say, unusual structures. How did you, is it your team always, or did you find some sort of local contractors? How did you manage to erect these structures around the world with this amount of professionalism? What type of challenges there is? That's all. Thank you so much, Michael.
Okay, thank you. Okay, regarding your first question, I had two advantages. First of all, I never wanted to be an architect. There was a real advantage because it was never for me a big aspiration to be a Frank Gehry or a Rem Koolhaas or a Zaha Hadid. No, this is not important to me. I struggled with architecture for a long time until I realized that architecture is just as good as many other disciplines to come to terms with an understanding of the world. So for me, it's a vehicle, not a kind of treasure trophy chest. Yeah, honestly, I'm very honored by the fact that you like the work that we have produced or in the past. I don't actually like the work very much, but I do like the insights gained through each one of the projects. They were always a learning experience, and I felt, and here comes my second advantage, my early realization that I had gained a lot of technical knowledge, but not really anything in terms of how to pursue design. In my study in Cologne, I had 2 tutorials on 8 design projects, which basically meant 6 projects I did totally on my own. And on 2 projects, I had 2 tutorials that consisted, in one case, out of a statement by the professor saying every design needs a slap in the face. And then I could go home and contemplate this koan. And the other tutorial was the guy asking, can you do this in steel? And I said, yes. And I said, okay, that was it. So nothing gained in terms of any instruction for how to do a design. So when I came to the AA, I was totally hungry to find something. And I had a professor that was new to the AA at the time where the AA was in a transition phase. And we did our own work. I didn't even understand, what do I have to do at the AA? This is all so strange. What do I even do when I'm asked to design something? And I remember that when we came with our first exercise, the guy said, you know, you have to stop thinking that you have to do things with reindeer blood and dwarf tears. Just have a process. And then I was like, yeah, well, I'm looking for a process. What kind of process? What do you have a process? No? Then the next trick is to understand the process, not as a straitjacket and not something that you repeat infinitely, but just as a way of getting a better inroad to structuring what you're doing, and to, if it's experimental work, to structure it in this direction. If it's other kind of work, to structure it in this direction. That's what I was looking for. So I was lucky. I was really lucky that by a whole series of realizations, misunderstandings, and opportunities, I had the chance to venture into that. So for me, architecture is something very different to a lot of the people that actually think that one needs to assert oneself and one's authorship and all these kinds of things. I'm interested in what the process and the result can tell us something about our understanding of the world, and maybe even advance it. Now is a very exciting time to do that. Unfortunately, it's a time of crisis. It's the crisis that is creating this need for understanding things differently, but it's also exciting. It's an opportunity. Now we need to do something. We need to understand environment differently. We need to understand the way in which architecture participates in the making of environment differently. So it's a new day with new questions. And all these questions, when they are pursued sincerely, they will never lead to an overblow of ego and saying, oh, but where's my signature in this? You will get your signature into it, don't worry, but face the questions, deal with it. That's what I would say. And the second thing is simply, the second question, we constructed everything that I showed, we constructed with the students ourselves. The textile membranes, when going somewhere, for instance, to Chile or to northern Norway, we produced them at the school and took them along because to have the sewing machine and all that was hard. But we had to have people in advance scout where we can buy the equipment and where we can get the machinery in case we have to mix some cement, etc. We did everything ourselves, with the exception of some precision welding that really needed to be done by somebody who does welding very, very well. Everything else was just done by ourselves, and it's a nice thing that the students in Norway all have a craft experience. So most of them know how to work with wood, how to work with certain things. And then there's the enthusiasm of being actually able to take an 18-week semester to design something in week 1 and to have it completely constructed in week 18, and to understand what a line drawn on paper actually entails in terms of labor before it really becomes something physical. That's just fantastic learning experience.
It is indeed.
Yeah. So it's not actually only scaled models, but actual thing that they build.
Well, in the scaled model, you already begin, if you have the full experience, then you can already see in the scaled model, if you do it faithfully, if the scale is not 1 to 500, but if it's a 1 to 50 model, a 1 to 20 model, you already see what difficulties you have to anticipate. Yeah. No? There were also things that went wrong on site, where we then had to slightly change a design, or where maybe even like when we arrived on site, the final bit of construction drawing wasn't finished. So we were starting constructing on one side, and then somebody was still drawing to get things ready to finish on the other side of the building.
Yeah.
Anyhow, you see, basically one of the important things for me was to change context in this kind of way. Sometimes it's about how you take these processes that allow us to do something different all the way to construction, so that the students have this full experience, beginning to end. Sometimes it's on an urban scale, where we can't do that, but then we have to ask different questions. What new sensibilities do we need? When we work with data from geographic information systems, we are usually working on territorial scales that are unfamiliar for architects. So what new understanding, what new sensibilities do we need to operate with data coming from that scale, and make that have a relevance on the scale on which we design?
Yeah, I think this brings us to that. Still, I think one of the challenges in computation and in design in general is the scalability, and how do we address that in the generative process, either computationally or in manually or physically? I think we need to move to the questions in the chat, so we don't.
Yeah, Ed has a question.
Where?
Ed has a question in the chat. What have been the biggest limitations in computational design that you have come across? If you don't mind, I will slightly change this question.
Yes, go ahead.
Because to my mind, what comes before limitation in computational design is the question or the disconnect between intent and available tools. Mm-hmm. So what I mean by that is you might want to do something and you realize that for what you want to do, the appropriate tool doesn't exist. And you have to resort to some tools which are not really fully capable of providing you this. Then comes the big question, what do you do? Do you actually accept that you're not able to fully implement what you want to do because the tool that is there was actually designed for a different purpose and so it's not capable of doing this? Or do you accept that you have to up your game and you may have to do your own tool? Now, in this time of Grasshopper, that might seem less of a daunting task than it was before. Before Grasshopper, we were working with software from Autodesk called Generative Components, and really to have any level of functionality change in these tools required a lot of knowledge in computation, a lot of knowledge. Today, with some Python scripting, you can already do some things. No? So what do you embrace? Do you say, I need to get quickly to my task, I don't have the time to deal with making the right tool, so I accept that my design will not be exactly what I want it to be because I have to do it within the existing constraints? That, I think, is the biggest question. And implied in that is the question of the limitations. How do you, there are limitations all the time, because if you want to do something new or slightly different, you look into your toolbox, the right tool isn't there. This is a limitation. And let's not forget that a lot of the drafting software, etc., that was originally produced was produced for a very simple purpose, not for the purpose that we want to do. Then nowadays, we're quite lucky that there are now many different software packages there, and you can have a look, what does this do versus that? I can model this geometry in this software and that geometry in that software. I want to do such animation or I want to do such simulation. Where do I find these tools? But at the same time, having now more tools in the box also requires more awareness and cataloging of what is actually there. So for me, for instance, opening finally Pandora's box and looking into geographic information systems is still a nice gift back of surprises of things that I was looking for but didn't anticipate to find there. Yeah, so the breadth of search for a tool to do something is important. And the moment when you realize that the tool that you need doesn't exist, you need to make a decision which way you go. These are the big limitations. Huh? But they're not only limitations, they're also opportunities. Everything else is more like a let's say, a second hierarchy problem. But the first level in the hierarchy is to face these questions.
Thank you. There's another question.
Yeah, then related to that, outside of your research, what do you think the future holds for computational design? Yeah, wow, this is a huge question. We'll see. I don't know.
Maybe like, did you anticipate, like 10 years ago, did you anticipate where we are now, or that was still like,
you see,
unsure?
No, you see, there's something
if we are going to get there or not.
There are some things that are happening which are really interesting, and that's why I find it difficult to. What does the future hold for computational design? I think the best moment that you can have for computational design or for any other combination of ways of working is when you begin to realize that you need to move beyond a certain accepted limitation. For instance, one thing that is now a big topic is transscalar design. So that basically means that you're looking at interactions between things which are operating on very different scales. So for instance, you have to design a small building, but there's also the condition of urban heat island, and maybe there is something to do with new green systems in the city, and all of a sudden you realize, hold on, this is connecting scales in a way that is quite different to how the disciplines are described and stratified. No? This used to be the domain of the planners, this used to be the domain of the architects, this used to be the domain of the landscape architects. And then you also realize we have two counter running movements. We have, on the one hand, the discipline that is producing more areas of specialized expertise. We have people that begin to be specialized in, I don't know, programming new tools. There are people who are specialized in greening facades and so on. But at the same time, while we have this fragmentation into these different expert areas, we also have tendencies which are pulling things back together. For instance, this issue of transscalarity, which is basically potentially restructuring the domains of the related disciplines that then may no longer be stratified in terms of scale bandwidth, but according to other expertise-related aspects. The same goes for interdisciplinary work. And I think that basically what you can see every time we find out that somewhere else there are some interesting tools, right? We realize we don't want to send the bulldozers in to modify the terrain. Can we work with the terrain as a resource? And then all of a sudden, you realize there are tools in geographic information systems that were not made for that purpose, but they could easily be used for this purpose. So it's not just a question sometimes of not finding the right tool for your purpose. It's sometimes you find tools where you have not expected them, but they may operate on another scale. So now you have to bridge this. And with this, new levels of synthesis come up. And I think that level of synthesis, that reintegration of different expertises and scales, which makes it possible to operate on more complex design problems, that's, I think, the future not only for computational design, but the future for design in large parts facilitated by computation.
Yeah. Thank you. Thank you. I think we are getting this crazy. Sorry for that. So I think there is a last question about do you think a part of human sensibility is lost when designing through a computer instead of a pen?
Yeah, people were saying this when the rotring ink pen was coming in. Oh, you know, now the line thickness is so uniform. I mean, what about all the... No, look. The best analogy that I can give you is one more tool in your toolbox is not going to make you less human. It just means you have a better toolbox. In the end, you're still making the calls and you're setting up processes differently. In the end, the bandwidth of how you can operate as a designer increases. We should be happy about this. Imagine everybody would just be playing the piano. We would never have a symphony orchestra.
It's more about how we use it and for what.
Yeah, sure. But, you know, there is no problem there. It's not the computer is going to kick you out. There are obviously questions related to issues of artificial intelligence. They're partly ethical questions. They're partly operational questions. Every time something like that comes up, we as humans feel majorly challenged. And I think in terms of AI, there's probably reason to have oversight over where this is going. So, this is one thing. But don't you worry, working with Rhino and Grasshopper is not going to reduce you as a kind of a human operator of a design process. It's just not happening. The same way as an instrumental design process doesn't do that. You are still sitting in the driver's seat. You just have a broader toolbox.
Yeah, thank you. Thank you, Michael, for your answer. I think Mirat has a. Are you there, Mirat?
Yes, I am.
Yeah. So we would like to thank again, Mirat, for organizing this and doing all the magic behind the scenes and making sure the gremlins are somehow mitigated in our streaming process. So I think you had a question, Mirat, to
yes,
Michael.
I mean, it's kind of morphed a little bit from listening because I hope the students are inspired as much as I am. I think, so the question is, in our MSc, in the new computational masters, we allow, or not allow, but invite more than just architects or people that have an architectural background. We ask, where it's open for engineers, and we have a student right now from media design and movies, and it was very interesting that you said you started you didn't want to be an architect. That was not your plan. And just reflecting on my own self, I went into computational because I thought I didn't want to be an architect. And so and that's why the masters allows, designers of all backgrounds. And so their question that is always, because it's such a big field that you're talking about, their question is, what am I going to be when I grow up? Essentially, after I graduate, what does that entail? Do I have to go into academia? As an architect, we know that we're going to be an architect, licensed, and there's a path. But what does it mean to be a computational designer? So yeah.
You're asking me this?
Yes, that's my question.
I don't know whether I can tell you whether I can give any meaningful response to that. But maybe I can go a step back. When I said I didn't want to be an architect, this happened around the time when I finished my A-levels, and my parents said, so what is it you want to do? And then I had some ideas, and they didn't really like it. And then they said, because my father was an architect, and my parents had to start their own business because of health issues of my father. They said, why don't you become an architect? So I had helped my parents a little bit at that time. And for me, being an architect was my very narrow understanding. What had I done for my parents? Draw terrace houses. Middle house left, middle house right, corner house left, corner house right, small modification to the stairway here, small modification to the window there. So I thought this is what's being an architect now. And then going to the construction site and making sure that everything is done the right way. That can be the life of an architect. So that was not the life of an architect I wanted, but since I didn't have any other experience, I couldn't really quite tell what an architect could be. Nowadays, I know that the sensibilities that you gain as an architect, for instance, to think in organizational spatial terms, is a particular skill set with which you can read the world and act upon certain things in the world. No? So I could also do that from another perspective, from the perspective of a computational designer. But right now, I cannot really tell you what a computational designer is, so I would have a very narrow perspective, and then maybe I would answer to you, oh no, I don't want to be a computational designer. I think the important question is, what is this skill set? How does a computational designer look at the world and operate upon the world? And that can be also quite different from individual to individual. I'm permanently trying, my trajectory in architecture is permanently trying to escape the gravitational pull of the discipline. No? I try to have this escape velocity, and I always try to get out of the discipline, but in a way, all I realized is I keep honing my understanding of the world based on my sensibility as an architect. No matter how far I try to diverge from the discipline, it will always be with me. So that's an interesting thing. It's an interesting thing. And if you keep enriching this and training and honing this this way of looking at the world and acting upon the world, it's a great thing. So don't take anybody's word on what a computational designer is, other than in most general terms of describing a discipline of looking at the world and acting upon the world. Everything else is up to you to tailor-make for your own happiness, being part of a discipline, if you want to use this word, or if you want to be part of a particular way of looking and acting upon the world.
Great. All right, we have 2 minutes left, so thank you very much. I'll let Lydia finish this off, and thank you.
Thank you, Murat, for your question, and again for allowing this to happen. We would like to thank you, Michael, for accepting our invitation and for your fascinating and inspiring talk. I think through your journey, through the experiences that you have shared with us, we can see, or I hope the students can see more, the connection between nowadays what they are exposed to immediately to the digital tools or the computational design, but no, it emerged from a need, and it was informed by the experimentations and the processes and the complexities that were involved, and also the scalability issues and the sensibilities that we try to bring in. I think you put it all together, and that was really fascinating. So thank you again, Michael.
It's my pleasure. So all I can really say, sharing a secret, stay young.
Sorry?
Stay young.
Yeah.
Don't get old in your mind. Stay young. Be curious.
Yeah. Yes. Yeah. Thank you. Thank you very much.
Thank you.
See you soon.
See you soon, and good luck with the course. And thanks for the invitation.
Thank you for joining
us. Thank you. Bye. Bye-bye, everyone. Thank you, everyone, for joining. Bye.